Hi everyone, Mrs. Schmidt here. I'm just going to take you through a quick tour of the SBAC practice test and work through a couple problems to help you familiarize yourself with it. So I always find the website by simply typing in SBAC testing. And then you can click right here. This one that says practice test and sample questions is the one that I always go to. You're going to choose your location as being California. And this green tab right here says Student Interface Practice and Training Test. If you click right here, you can do guest user, guest session, just like that. Click down here on Sign In. Give it just a minute to load. We're going to look at the 8th grade SBAC test. You'll see you have your Smarter Balance practice test here, grade 8 ELA, grade 8 math, training test, and that's all you really need to worry about on this page. Your performance tasks are over here as well. So we're going to look at math today. If you click right here to open up math, this should all be set to standard settings, so you can just click select. It's going to test your video and sound playback. And I heard that just fine, so I click I could play the sound and video, continue, and then begin test now. So this is a way for you to log in and go through a practice test if you would like to. I'm going to work through a couple problems just to show you the different functionality within this practice test. Again, get you familiar with it, and yeah, let's do it. So this is question 1. It shows you the question you're on up here. It shows you the percentage complete, and then it reminds you of the test that you're on. So this first question right here says enter the value of n for the equation 5 to the n power equals 5 to the 11th power times 5 to the 3rd power. So we're talking about exponents, which are one of my favorite things to talk about. Let's draw this out. So we're solving for this n right here, and we're multiplying. Remember that dot means to multiply. So it wants to know 5n equals 5 to the 11th power times 5 to the 3rd power. Keep in mind when we're talking about exponents, let's look at 5 to the 3rd. We have our big base, which is our big number, and our extra small exponent, which is 3. And 5 to the 3rd power means 5 times 5 times 5. 5 times 5 times 5. It does not mean 5 times 3. 5 to the 3rd power means 5 times 5 times 5. So 5 to the 11th power means 5 times 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 5, 11 times. So I'm actually going to draw that out. 5 times 5, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Woo! So 5 to the 11th power in expanded form is all of this. Let me count to make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we can't forget about this times button right here. So times, and then 5 to the 3rd power, like we already talked about in expanded form, is 5 times 5 times 5. So 5 times 5 times 5. Okay, so 5 to the 3rd is 5 times 5 times 5. So 5n equals all these 5s times each other. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 5n equals 5 to the 14th power. Okay, let me change this color and just show you. N is 14. Now, I like to draw it out. It helps me. If it helps you, draw it out. It's going to take a little extra time, but who cares? You're going to get the problem right. Expand it out if you need to. However, if you know your exponent rules, you know when you're timesing like bases, remember the base is the big number, and these are alike, 5 and 5. When you're timesing like bases, all you have to do is add the exponents, which makes sense because that's what we did here when we expanded it out. 11 plus 3 is that 14 right there. So I can now put in my answer of n equals 14. N is my variable. It's my unknown value. N equals 14. I'm going to save that because I am sure that's right. And I'm going to click next. Ooh, graphing problems, my favorite. The distance d in meters a car travels in t seconds is shown in the table. Now, the first thing I want to make sure you do is look at your table, look at your graph, make sense of it. D is distance, t is time. Okay, it says use the add arrow tool to graph the proportional relationship between the distance, d, traveled by a car and the time. This totally makes sense, right? Because as a car travels, the further it goes, which is the distance, the longer it's going to take to get there. So our distance, when the distance is 10, it took 1 second. So if you look, I have my time here and my distance here. So when I have 1 in my time spot, I have 10 in my distance. So if I go to 1 on my graph on my x-axis, or here it's the t-axis, I go to 1 and then I go up to 10. It wants me to put a dot right there. I'm going to do it with my erasable tool first to show you a couple, and then we'll do it with the actual program. But when t is 2, it's 20. So 2 is 20. And when t is 3, it's 30. So 3 is 30. You get the hint. So let's actually use what it's telling us to use to graph this. And remember, it tells you use the add arrow tool to graph the proportional relationship between the distance d traveled by a car and the time. So if I look, even if you've never done one of these tests before, you would see the add arrow tool. Where's the add arrow tool? Right there. Select 2 points to connect with the arrow. So my first point I know is here, and my second point is here. Okay? So use the add arrow tool to graph the proportional relationship between the distance traveled by a car and the time. And you could actually, what I would probably do is plot your first point. 1 is 1 in 10, and then 5 and 50. Let's see if I can do that. Oh. Here we go. This is why we're practicing, right? Because Mrs. Schmidt is now stuck. Release the mouse button to place the object where you want it. I want it here. And there. There we go. So again, I was clicking around and I couldn't figure it out, but it actually gave me a little hint right there. So there you go. I have now graphed